Hello, in this part 2 of our MQTT how-to series, we'll pick up where we left off in our last video, and we'll use an extended options file to facilitate the reformatting of our published packets so that they can be fed directly into an IBM Watson IoT platform dashboard. Here we're back to our configuration file from the previous video. We're going to make some changes though. Instead of publishing each packet as it arrives, we're going to define our own custom report packet to aggregate the data from each of the sensors, and then set a continuous timer to publish our custom packet every 4 seconds. For now, we're just going to use the extended options file to flatten our JSON packets, and we'll review that in detail shortly. But first, we'll push the updated configuration file to our device running the SoftHub daemon. When using extended options files, they and their associated JSON filter format files must be present in the same configuration file directory as the ruleengine.xml file. Example template files are copied to the directory during installation, so we'll copy the template to the file name we specified in our publish report action objects, and then edit that file directly. In looking at the extended options file, we're going to keep our review brief as all the individual fields are well documented in both the OmnIoT SoftHub user guide and in the example template files themselves. But in general, an MQTT extended options file includes the following subsections. The first section allows the user to set many of the base MQTT connection parameters. Some of these parameters overlap with the values you can set in the SoftHub configuration utility directly. It should be noted that when conflicts arise, the value specified in the ruleengine.xml file will take precedence. For our example, we're going to change the flattened JSON value to 1 so that we can see what our custom report packets look like in the flattened format. We'll use that information later to transform our packets to a format suitable for sending data to an IBM Watson IoT dashboard. The next section allows the user to control the MQTT connection's last will and testament settings, followed by a section to set any extended SSL options required for TLS encrypted connections. Next, there's a section providing the user with the ability to filter and format outgoing packets to meet the specifications of any third-party target platform. There are 2 types of control parameters in this section. The first, publish unformatted, simply dictates whether packets that don't meet any of our user-specified filtering criteria are published or discarded. The second, a list of up to 16 JSON filter format files, allows the user to specify additional files in .jff format to do the actual filtering and reformatting of outgoing packets. We'll return to these files shortly. And lastly is a section where we can map incoming control messages to user-defined events to be queued, allowing for a very flexible model to provide for remote control of your SoftHub from cloud-based dashboards or mobile applications. For now, let's save our file with our updated flattened JSON flag and restart the SoftHub daemon. Again, we're using the MQTT FX utility to capture the resulting packets, and then we'll put the packet through JSON lint to get a formatted version of the packet. So now that we've had a look at our flattened packet, let's look at what IBM documentation says our target packet should look like to be properly formatted to publish our data to an IBM Watson IoT dashboard. Here we've copied an IBM example and reworked it for the data we'd like to publish. From the report packet we'll generate, we'll filter on 2 label value pairs to be sure our transformed packets are derived from the source packets we think they are. For this example, it's not really important to do this since we're only generating 1 type of packet. But in general, it's a good idea so that any future packet types we may add to our configuration don't get inadvertently transformed incorrectly. So from our source packet, we'll select for only packets that have a packet type of JSON report and a report name of weather report. Next, referencing the IBM example packet, we've created a similar output format string to match the example packet. We've put placeholders in the string for the 3 data values we're going to publish. Again, looking at our flattened packet, we found the labels for the 3 data values and specified them as our corresponding variable labels. So to summarize, if a generated packet has matching label value pairs for the 2 pattern match strings we specified, we'll pull the 3 values from the 3 variable labels we specified, and those values will be inserted into the output format string template, each replacing the %s placeholders. Now we'll create our .jff file on the SoftHub device and also update the MQTT configuration file we created previously to reference the JFF file we've added. We'll again restart the SoftHub daemon and look at the newly reformatted packets as they are now being published. We can see that the packets are now being transformed correctly and are in the proper format to be sent directly to an IBM Watson MQTT broker. We'll go back to our original rule engine file and change the connection parameters with the address and credentials needed to create our IBM Watson connection. We'll again push the updated ruleengine.xml file to our SoftHub device and restart the SoftHub daemon. Now let's look at our IBM Watson IoT dashboard where we should see our packets arriving shortly. Using the SoftHub's ability to change published packet formats on the fly allows us to be able to communicate directly with literally dozens of third-party cloud-based IoT solutions. Our full-featured MQTT interface means that you can generally connect to your chosen MQTT broker and begin publishing your sensor data in a matter of minutes. Again, thank you for watching our MQTT How-To series. To control your SoftHub or connected sensors from the cloud directly, watch our follow-on MQTT introduction video titled Remote Control Capabilities. You can find a link to the video in the description below. And as always, if you have any questions or comments, please don't hesitate to contact us directly through the OmnIoT website at www.omniot.com.